I was wrapping up my work. I actually slept. I was really tired, so I slept, and some pending work was there. So that's why it took time. Apparently, there was big O notation and n square, which was causing issue. So the way the query was written, the way the logic was written, algorithm was written, it was multiplying and then it was scaling, and where it should take like 2 seconds to load the page, it was taking like 32 seconds, 35 seconds. Imagine the user would have gone by that time. So that's the power of big O notation. Sometimes if it's an n square, then it's just going to multiple and scale, uh, depending on, because it's dependent on the size of the problem, right? The n can keep getting multiplied.
Can you explain to me how do you find out the big O? Like I've seen it written like this is O of n and this is O n log n. But
Yeah.
is there a way to find out?
Did you watch the video? If you watch the video, you'll know it. But yeah, I'll give you a brief summary of how that
Yes.
works. I shared one of the videos. You explain that. Uh, so, like for example, if there's like a single loop, okay, I equals 0, I is less than n, I plus plus. If it's a single loop and whatever is happening, then the big O notation for this one is going to be just n, because there's just one loop. But imagine if there's going to be loop within the loop. Maybe this
Hmm.
is like a, whatever. Then this becomes n square. Okay. And there's another one maybe within the loop, it becomes n cube and so on and so forth.
Okay, understood. And when is log n log n?
N log n. I think this was n log n. 1 second. X equals
When there's recursion, it's n log n.
When you're
possible.
dividing repeatedly, then you have logging.
Got
Okay.
it. Okay. Okay, that makes sense. Thank you. Are you guys scared?
I am. I'm 100%
Yes.
very much scared. Especially scared because what Sajjan and Ashish received in terms of the paper.
Hmm.
Why do they have to make it tough, yeah? Just get on with it. Just copy the previous year's paper and make our life easier.
Yes.
They anyways give less marks. They don't really give good marks. And I've heard that.
I was reading some Quora answer or something, and somebody had written. So in the first semester, I was like super scared of everything. Like now, I still know what happens, but in the first semester, there was one Quora answer, and they said that it was some. It was also computer class, and they said that they were a class of 50, 60, and only like three of them passed. Like, what
Oh.
the hell is this? So, and that really scared me. But with us, I guess it's not that bad. I mean, we don't
Yeah.
get good marks, but at least the whole class doesn't fail. So yeah.
Okay, so I want somebody else to read it while I'm having tea. Anyone can pick up.
Sure, I will do.
Okay.
Yeah, so it's time complexity and space complexity. Generally,
Mhm.
there is always more than one way to solve a problem in computer science with different algorithms. Therefore, it is highly required to use method to compare the solutions in order to judge which one is more optimal. There are two such methods used.
Mhm.
Time complexity. Time complexity of algorithm is a representation of amount of time required by the algorithm to execute to completion. Time requirement can be denoted or defined as a numerical function Tn,
Mhm.
where Tn can be measured as a number of steps provided each step takes a constant time. For example, in case of addition of two n-bit integer, n steps are taken consequently. The total computational time is Tn C into n, where C is the time consumed for the addition of two bits. Here we observe that Tn goes linearly as input size increases. Space complexity. Space complexity of an algorithm represents the amount of memory space needed by algorithm in its life cycle. Yeah. Space complexity. Space needed by the algorithm is equal to the sum of the following two components: fixed part and variable part. The space required to store certain data and variables that are not depend on size of the problem. Variable part. A space required by variable whose size is totally depend on the size of the problem. For example, recursion, stack space, dynamic memory allocation, etc. Plus complexity SP of P algorithm is SP is equal to A plus SP of 1, where A is treated as a fixed part, S of S of I is treated as a variable part of the algorithm, which depend on the instance characteristic. I following is a simple example of tries to explain the concept.
Okay. Um, so basically, there are more than one way of solving a problem, and to decide which one out of those is optimal, there are two methods. One is time complexity, and second is space complexity. Time complexity is represented by the time taken by the algorithm to complete its execution, and space complexity is the organization of sorry representation of the memory or space required by an algorithm in its life cycle. And time complexity is represented by a function Tn. For example, the addition of two bits, and in the addition of two bits, we have is represented by T n equals c into n, where n is the number of steps and c is the amount of time taken for each step. It grows linearly in this case, and space complexity uh, depends on two components actually. One is the fixed part and second is variable part. The space required by a variable. So in the fixed part, this is space required by the data and variable uh, does not depend on the size of the problem, uh, while the reverse is true for the variable part. And it'll be equal to S. What is that? S. Let's see. What's that?
S S of P is equal to a, a A plus
Plus
okay,
Si.
A plus Si, yes,
A is the fixed part.
where A is the fixed part and I is the what it depends on
Variable
variable.
part.
Hmm.
Yes. Okay. So this is the example where step one starts, step two R equals P plus Q plus 10, and then ends with stop. Okay. Oh, difference. Let's keep haunting us. So total time taken. So time complexity is calculates the time taken, and the space complexity takes calculates the space or memory taken by an algorithm. The algorithm for the merge sort and time complexity algorithm for merge sort is n log n, and space complexity for algorithm for merge sort is O, is it O n square?
No, ON.
O n, okay. O n.
OFN.
And then there was something about the optimal solution, time complexity requires optimal,
Yes.
needed for optimal solution, and for space complexity it is not, doesn't matter that much because of the modern hardwares. And time complexity is calculated based on all the number of statements. Space complexity is calculated based on all the variables including input and output. And there's one more point. What was the other point?
Auxiliary.
Yeah, auxiliary. Yeah. So time complexity depends on the input data. Space complexity depends on the auxiliary variable size. Okay, Sajjan, let's read this.
Sure. Time complexity and space complexity differences. Time complexity calculates time needed, calculate memory space needed, count time for all statements, counts memory space for all variable, even input and output. Depend
Uh,
mostly on input data size.
Sorry to interrupt you. Is your earpiece very close to your mouth? It feels like you're chewing it.
Okay, sorry. Now is it okay?
Yeah, much better. Thank
Yeah. So depends mostly on the auxiliary variable size, and is more important for solution optimization. It's
you.
less important with modern hardwares.
Hmm.
Hello. Yeah.
Yeah, yeah.
Lastly, time complexity of merge sort is O n log n. Space
Hmm.
complexity of merge sort is O of n.
Okay. Now we need to write an algorithm to bubble sort in ascending order. Um, so let's write that. So we decided that we're going to do all these problems one day before the exam. So we'll do that. So we need to bubble sort basically an array. So in step one, we just begin and then uh, get the length of the array, get the array also, I think, and hold it in variable called ARR, and the length probably can be n. Then we have to start the loop from second last item to the first item, I believe. So
No, from second item to the last item.
last item, sorry, second item to the last item. So that begins for I equals. Second item will be 0. Okay, so second item will be 1 for I 2. Last item will be n minus 1. And then we have to,
Can you also explain this? Why was the last item n minus 1? Why not n?
because the index starts from 0, that is why n minus 1. So
It
let's say we
starts
have 1. Mhm.
it starts from 0, that's why I is equal to 1. I get that. But why n minus 1?
No, no. Starts from I equals 1 because we have to compare the two elements. If I started from the end, what am I going to compare with? So that's why we are comparing, starting from the second item, so that I can, uh, compare it with the previous one. Okay, and then it's going till
The
the
last
end.
index is n minus 1 because the count of the items is n and we're
Hmm.
starting from 0.
Oh, okay.
Got
Okay.
such a
Okay.
big
Got it.
notation.
Got it. Got it.
Okay, so now we have to check if the elements are not in order. Or we have to run another loop, I believe. Not here. We have to run another loop, right? Maya?
Yeah.
Loop from now where do we loop it from? Here?
From last element.
Last element to the current element. Or the last element would be what? N minus 1
Yes.
to current element is I, and check if the elements are not in order, which is if, or if we don't need to do if, um,
You should
array
put j equals n minus 1.
where
For the second for loop, we need j.
take from here, array j less than equal to array j minus 1. Yeah. They won't be equal to, right? We established that yesterday. We remove the
Yes, you
equal.
can remove equal to.
So if that's so, then swap array j with array j minus 1, 8 algorithms. Okay, so if that's so, then swap it, and then I don't think there is anything else we need to do, just to end it, right? Yeah, that's it. So again, a recap, and then I want somebody else to do it. So let's see, read the array and length of the array. So instead of get, we'll say read the array, hold it in this, read the length of the array. That will be n, and that will be this. Add the loop from the second item to the last item, I equals 1 to n minus 1, loop from the last element to the current element, j equals n minus 1 to I. Check if the elements are not in order. If this less than this, then swap them, otherwise don't, and this will just continue, and that's it. So maybe is this correct, or we missed on to anything?
Looks correct.
Okay, now let's have somebody else do it. Kritika, you want to try now?
Yes. Okay.
Feel free to take help from the slides. I don't expect you to remember everything.
No, today you can expect me. I've studied. Hopefully. Yes. I'll try to do it on my own, and if I can't, I'll.
That's fine.
Okay. Begin.
Mm-hmm.
Read length of the array. That is n. Loop from the second element to the last element.
Yeah, Kritika, if you get above 60, you have to treat all of us.
Done.
Okay.
For sure.
Okay.
I actually want to thank you guys, like, and the party will be like a good way to do that. So yes,
Yes.
if I get 60, I will definitely.
Awesome. We'll have social celebration, social online celebration.
Yes, okay. A Zomato, you guys.
Yes.
um,
Yes.
I is equal to, no, sorry, for second element is second
So the
where
index
it is
starts from zero.
I is equal to 0.
No. Second
2,
element. Wait, wait. Second
second
element.
element will be 1.
Correct.
2, last element is n minus 1.
Yeah.
Then you loop it from the last element to the first element, which is I is equal to n minus 1 to the current element here, to I. Then then we check, compare the
In the
arrays,
second loop, we should use J.
right? Compare the arrays if array of um, j is
Yep.
equal to
No, no, less than.
array less than array of j minus 1,
Hmm.
then you swap array j and array j minus 1, j
Yep.
minus 1,
Use
and
square brackets, not round brackets, for with the array.
right.
No, 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 no. With
No,
the array.
for this one.
Yeah, with the array.
Okay. Okay.
Change the length of the array to just n at the second line,
To
because
just n.
length of the array will be held in just n.
So
Remove
what
the
do I do?
remove the array.
Which
Remove it.
array?
Yeah, that one.
Only
That one. And just n, because length will be n, right?
and read length, which is n. Okay.
Yeah, and then
Actually, you don't have the array.
you also have to read the array also, right? So not only read the length of the array, but also read the array. So first, second line will be, yeah, that's fine.
Hmm.
Read the array and read the length of the array.
Okay. Array lines. Got it. And I'll
And
check.
make a square bracket after the array. Yeah, much better. And end it with the round bracket. No, that's fine. And that with
This
the
was
round.
fine.
Swap,
Hmm.
consider swap as a function. The function takes arguments, right?
Hmm.
Now it's fine.
Okay. 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 This helps here. I think so. Okay.
Good, good. Let's have Somaya do this now.
Okay. So begin, then read array and its
You're
length
not
n.
sharing. You're not sharing.
Oh,
She is sharing. You have to add it. Add it to the stream. Are you not able to add it to the stream, Somaya?
I don't think I can add it.
Okay, I added it. Okay.
Okay. Now can you see?
Yeah.
Yes.
Okay. Then loop from second element to the last element. for I equals 1 to n minus 1, and again loop up from last element to current element. Or j equals n minus 1 to I. Then compare
Can you zoom in a little
compare
bit?
adjacent elements.
Yeah.
Check if array j is less than array j minus 1. So then swap them. And then end. Is this correct?
It looks right to me.
Okay.
If we have to swap it if we have to do it in the descending order, we will do the opposite, right?
Yes. The if condition will be opposite.
Okay. Yes, okay. I like bubble sort. It's
You like?
simple. Yes, I mean
Yeah,
it's easy
this is
to
the
understand.
simplest.
Okay, let's move on.
It's also the slowest one.
Yeah. Let me share my screen.
It's similar with insertion also. It's slow, but it's very easy.
Hmm. So iteration 1, I equals 1. Let me show the switch. So this got swapped because this was larger. So every time this is larger, they're going to be swapped. In our algorithm, what did we write? You're saying j is less than array j minus 1, which means the same thing. You should have written like that.
Yeah, like if array j minus 1 is more than array j
Yeah,
minus.
yeah, correct. Probably make more sense. They're looking at that algorithm. Better. Because that's how it looks like here. This is greater. If the j minus 1 is greater, then swap it. Otherwise, don't. So in this case, it'll get swapped. This is not greater, it didn't get swapped. This is not greater, it didn't get swapped. Again, this is not greater, didn't get swapped. This was greater, so it got swapped. Okay, then in the second iteration, I equals 2. And then you just have to repeat that. Okay, fine. Stack is a linear data structure. It follows first in and first out principle. And there's just one end, which is the top, and the pointer is always pointing to the top of the stack, and the elements can be added from the top and removed from the top. Right? I don't think we have to discuss anything here. Linear data structure follows LIFO, last in first out. Stack has one end where Q has two end, contains only one pointer, top pointer, pointing to the topmost element of the stack. Whenever an element is added in the stack, it is added on the top of the stack, and the element can be deleted from the top of the stack. In other words, a stack can be defined as the container in which the insertion and deletion can be done from one end, known as the top of the stack. Suppose we want to store the elements in the stack. Let's assume that stack is empty. We have taken the stack size is 5 as shown below, in which we are pushing the elements one by one until the stack becomes full. Since our stack is full as the size of the stack is 5, in above cases we can observe that it goes from top to bottom. When we are entering the new elements in the stack gets filled up from the bottom to top. Okay. Following the operation on the stack, let's each one of us do a pair. So I'm going to take the push and pop. Push pushes the element in the array and pop pops the element in the array. Kritika, give me a pair.
Peek and count. Peek is used for the first element, and count is used to count all the elements.
Okay.
Is empty and is full to check if the stack is full or if it's empty.
Yeah. There should be another pair, right?
Yes.
Display and what? Change.
Count.
No, display and change.
Oh.
No?
Oh. Okay.
Display displays all the
Sorry, I
elements.
forgot.
Changes the element at a given position. So we have push and pop, then we have is empty,
Right.
is full, change and display, peak and count. Let's see. We can count it together, see? Change and display together. Cool. Write an algorithm to reverse a string. Let's do that. So begin reverse a string. Read the string S. Read length of the string N. Create an empty stack. I hope my keyboard is not too noisy. Is it?
It's fine.
Okay. Okay, create an empty stack. So it will be stack equals create stack. Then loop through the string characters and push it in stack. We'll say push stack, comma, S I, and I didn't run the loops. I have to run the loop also for I equals 0 to N. Loop through the string characters and pop items from the stack. I, oops, loop. I keep forgetting the loop. Maya reminded me yesterday. So pop, this will be S, oops, I equals pop stack. Okay, and then print the reversed string and then end. So Maya, is there a problem here anywhere? You see?
Loop to n minus 1.
Okay. Okay, add that here. Yeah. Here it is. Should use n equals length. and so length of s, sorry. And read string s. Fine.
Yes, looks good.
Okay, Kritika, your turn now.
Okay. Can you see it?
Yeah.
Okay.
Sajjan, where is Ashish? Why didn't he join? Is he not giving exam? Sajjan, are you there?
Just
Okay, read the string s and its length. Okay.
then.
Make a square bracket after s because it's an array.
Okay.
No, no, no. After s, not inside.
After S.
Yeah. Make an empty square bracket.
Oh.
Yeah,
Okay.
like that. Yeah. You have to
Just
first create a stack.
create stack. Stack stack is equal to new stack.
No, create stack. Camel case. Yeah, that was fine. That was fine. Camel case. That is the camel case. This is Pascal case.
Create stack. Empty. Yeah, those brackets.
Fine.
Push the characters
Mm-hmm.
to the stack. Yes.
By looping through.
By loop through I is equal to 0 to n minus 1.
Yeah.
Then I've pushed the characters, now pop the characters.
No, no. You have to use push function to push it. So move that line push below the loop. Yeah. And then use push function, which you learned in the operations. So it takes two parameters, stack in the round brackets,
Stack
comma, comma, si.
is I in
Yeah, correct. I small letters. Yeah, close. Yeah, close.
close brackets.
Yeah. Again, loop through before popping. Just copy paste from the top and then pop.
Characters from the stack.
Hmm. By the way, stack is stack and not s, the variable name. Yeah. So no need to write variable name. It's fine. It's understood.
Okay, this from stack. This is true
Pop.
for I is equal to 1. Here also for
No, you are already looping through. You're already looping through. Now you have to pop it. So you have to call the pop function. You're already within the loop.
Stack S I
Use the pop. Yeah, this is correct. Yeah, this is correct.
I is equal to pop stack.
That the stack goes in the bracket. The pop is a function like pushes.
I am
That's it.
gonna mess this up.
So this is fine.
Yeah.
And you have to also print
Yes,
the
I was
character.
going to do that.
Yeah,
The characters. So I print the characters.
that's it. Nothing else.
Okay.
Or you can say print the reverse string instead of characters.
First string.
That's it. Nothing
Okay,
else.
so I'll summarize. First,
Yeah,
I read the string and its length, which is what we do for everything.
yeah.
Then we create the stack.
You
By stack is equal to
an
create
empty
stack.
stack.
Create an empty stack.
Yeah.
By stack is equal to create stack. Loop
Mm,
through. I know the loop. And then
mm,
push the characters to the stack. So push
mm.
stack si. This is the array.
Yeah. Array is so when you say si, which means you're passing the index dynamically. In each iteration, the value
Yeah.
of I will change. First, it will be
Change.
S0, S1, S.
Yes. Okay, and then loop through and then pop it. Loop and then pop.
Yep.
Okay. Okay.
Cool. Let's move on to the next one. Okay, so algorithm to insert an element in a singly linked list. Allocate new node. If new node equals null, write overflow, go to step 6. Set new node data equals value. New node next equals head. Head equals new node, and then exit. Then insertion at the end. Allocate new node. If new node equals null, write overflow, go to step 7. Set temp equals head. Traverse to the last node. If while temp next not null, keep incrementing the temp. So set temp equals temp next. Set new node data equals value. Set temp next equals new node. Okay, exit. Insertion in the middle. Allocate new node. If new node equals null, write overflow. Go to step 7. Temp equals head. Traverse to the node just before the required position. So there we were traversing to the last node. Here we are going to traverse it to the one for which we have been given a position where we want to insert it. So for I equals 1 to the position, if temp next not equal null, set temp equals temp next, set new node equals value, new node next to the temp next. Um, okay, and then temp next is equals new node. Sumaya, where is the new node next over here?
That one I missed. We should put new node next is equal to null.
So new node next is equal to null, right?
Yeah, because it's last.
Can you update that?
Yeah.
Okay. Okay. So let's try it. Hello?
Yes.
Okay, so we're gonna begin. Basically, we want to insert an element at the start of the linked list. So first, we are going to allocate a new node, and then we're going to check if new node is equal to null. And we're going to write overflow and exit. If that's not the case, then we're going to set the new node node equals value, new node next equals head, and then head equals new node, and am I missing anything? Let's see. Okay, allocate new node if new node equals null, write overflow exit, new node data. Data equals value, and next is going to be head, and then head equals new node, and then exit. Yeah, that's good. Then again, if you want to insert an element at the end, so this was in the beginning. Insert in the beginning. This will be insert at the end. We'll say begin allocate new node if new node equals null, write overflow, and then exit. Else while okay, create temp equals what? Temp equals what?
Head.
Okay, while temp next not equal to temp equals temp next, or temp next equals something.
No, temp equals.
Temp equals temp next, right?
Yes.
Kind of incrementing it. Okay, so temp equals temp next. Okay, and then we say new node data equals value, new node next equals temp. Oh no, new node next is going to be null, and then temp what will be the last line on this one?
Yes, temp next equals new node.
Why we're doing this?
Because new node is last after temp. Earlier temp was the last node. Now we're putting new node after that.
I think, Sumay, what would be helpful is to just add a comment after each line, because it's very easy to forget what's happening. Maybe somewhere here if you can add like a comment, maybe even if you want to create a table or something, something like this for me, that'll be helpful. But then in exam, it's very hard to forget. So let me show you what I mean. Like generation. So this is self-explanatory. The things that are self-explanatory, we don't have to do anything. But like places like this, loop through uh, the nodes until we find the last node, because next pointer of last node is null. Something like that. So no, that will be easy to understand. Now at this line, this is also a good point of explanation. So we are incrementing the temp to point to the next node in each iteration. This is self-explanatory. We are doing that. We set the new node next value to null because the last node next pointer is always null. Send the next temp next to new node because temp next to new node because the previous temp next is the previous node, which should point to the next node. Is correct what I've written? So may I can see this?
Yes.
Is correct?
The last one, because temp is the previous node, which should point to the new node, to the next node, not temp next.
Okay.
Yes.
So it will help you understand what's happening on each step. I'll remove this guy, not needed, because it's missing. Oh, you already put the null there. Good. Okay, I'll leave both of them. Just in case if you want to see an explanation, you can look at on the right. Okay, so now next thing is that we want to insert at a given. This was the at the end, yeah. Okay. Insert node in the middle. For that, 1 second. So begin allocate new node, then if new node equals null, then write overflow else exit, and then we have to basically loop through up until the given position. So loop through to reach given position where we want to insert the element. For I equals 0 to the position, and with this I'm going to say while we have to get the temp also. Set temp equals, so what will temp be here? Will it be still be head?
Yes.
While temp next is not equal to null, temp next, temp is equal to temp next, right?
Inside the for loop, there's an if condition, not while.
Right?
Yes.
Temp equals temp next, and then it's a new node data equals value, new node next equals that's going to be temp next, and then temp next equals new node, correct? Are we missing anything?
I think it is correct.
Let's verify. So new node null temp equals head, traverse is node just before the required position, temp next is not null, then temp
Yes,
equals
correct.
temp next, new node data next. Okay, so I'll just place that there. Okay. Until we find
It should be position -1 because we are going to the node before the position. Or
can you
here it
update?
was I equals 1 to position.
Oh, okay. So it should start from 1.
Yes. We're not using I, so it doesn't matter what it starts from.
So should it be position -1 here in this case or not?
No.
But if I use I equals 0, then I have to.
Yes.
Loop through the nodes until you find the given position, until we reach given position. Then we are incrementing the temp to the next node in each iteration. Go until the last node. Then we set the new node next value to temp next, because um, the new node should point to the so temp next is basically the next node, right? Okay.
Yeah, we're putting new node between temp and temp next.
Yeah, I think it'll be nice if we can have a diagram. So Maya, can you find a diagram and paste it there?
Yes, I'll check.
Yeah. Set the new node next value to the temp name because the new node should point to the next node. Temp next equal to new node. So new node because temp is the previous node, we should point to the next node, which is new node. Yeah, this is fine. I would say let's break this into 2 slides. It's getting very heavy. Let's get rid of that. And then you'll be able to paste a diagram here. Move these guys. Okay. Okay, Kritika, let's try the first one. You want to try? Confident?
No, I'm not. I'll,
Do one.
I,
Do,
yeah.
do one thing. Take a reference and do it. The main thing is to practice. It's okay if you take a reference. At least in the first iteration, you will remember something when the next time you do it. So just do one and take help from the slide. Do the first one.
Okay. Okay.
You know which one's the first one where we are
Yes.
inserting the start.
Inserting. I'll share the screen. Share.
They should give 20
It's
marks for
it's
it's
sharing,
only
right?
1 sec. Sajjan, are you there? Sajjan? I think he's just in and he went somewhere.
Okay. Okay.
You know what? I think in the exam, even if you can create a diagram, that'll have an impact.
Yes.
You'll get at least few marks for that. So even if you're not able to crack the algorithm, if you put the diagram and if you have an understanding, examiner will know.
Yes. I was thinking that too.
Yeah.
Yes.
So do one thing. Sorry, Kritika. Paste the
Hmm.
diagram there, and then try to write it. In the examination also, just create this diagram
Yeah.
and then write it. You'll get some reference probably. So allocate a new node. Then we check if no wait, if new node equals null,
If new node equals null,
then write over.
overflow
Put it in the
overflow
next line.
or exit. and then exit.
Yeah.
And start. And if new node is null, write overflow and then exit.
Yep.
If it is not, then set new
Yep.
node, new node arrow,
So it has two parts, right?
data and value, data and next.
Yep.
Data is equal to value set new node arrow
Next.
next is equal to, because this head, then
Set.
set
Head.
head is equal to next
No,
is equal
new
to
node.
new node.
Yeah. Because head should point to the new node.
It's
See
a
the
point to
diagram.
the
Come to know. See, go and check the diagram. See, initially head is pointing to the old
head
node.
is pointing to the old node. Yes.
Right? That's
Now,
why in the second last line of yours we set the next to the head because head that had that value. It was holding that value, so we grabbed it from there.
yes.
And then in the last statement of yours, we are setting the head to point to the new node. That's it. Not bad.
Yes. Okay.
Okay, let's move on to the next one. I'm gonna share my screen. So, may have got some pictures.
Yes, I got some. I
Okay.
like them.
Okay, great. So now we talk about a tree. The tree is a non-linear data structure, um, and it is used to store the hierarchical data. It has a root. It has children. Adjacent children are called siblings. Each of the nodes have some data which could be of any data type. The children which do not have grandchildren, or sorry, the nodes that do not have children are called leaf nodes, and that's about it. Critical, let's just quickly read this. 1.25.
Okay. A tree is one of the data structures that represent hierarchical data. Tree data structure is defined as a collection of objects or entities known as nodes that are linked together to represent or simulate hierarchy. Okay. A tree data structure is a non-linear data structure because it does not store in a sequential manner. It is a hierarchical structure as elements in a tree are arranged in multiple levels. In the tree data structure, the topmost node is known as a root node. Each node contains some data, and data can be of any type. In the
Yeah.
above tree structure, the node contains the name of the employee, so the type of the data would be string. Each node contains some data and link or reference to other nodes that can be called children.
Yeah.
The nodes that do not have children are called leaf nodes. Yes.
Hmm. Okay, so how is a tree different from binary tree? From this picture, I can say that it's empty, non-empty. So a binary tree can be empty. Nodes in the binary tree can be empty. However, the general tree cannot be empty. We already established that the general tree, the number of children, um, there's no limit on that. However, in binary tree, you can have a maximum two children, and there was a point attached to that, which is uh, the degree. There's no limit on the degree of the uh, nodes for the general tree, but there's a limit on the degree of nodes for the binary tree because you can only have maximum two children. Um, then what else? What else? What else? What else? Yeah, there was one more point at the bottom, the last point, which was a binary tree can have left subtree and right subtree. However, a general tree can have any number of subtrees, zero or more. And what else? what are the other points? Kritika, do you remember any others?
No.
Sumaya?
No.
Okay, no problem. So let's take a look. General tree is a tree in which each node can have many child nodes, whereas binary tree, each node can have at most 2 nodes. Subtree of general tree do not. Oh, how can we forget this? Ordered property. While subtree of a binary tree hold the ordered property. Uh, in data structure, generally it cannot be empty, while the binary tree can be empty. In general tree, there's no limitation on the degree of the node, while in binary tree, there's a limitation in the degree of node because the nodes in the binary tree cannot have more than 2 child nodes. In general tree, there's either 0 subtree or many subtree, while in binary tree, there are 2 subtree, left tree and right subtree. So it's not bad. I mean, if we have forgotten just one out of the 5, it's not bad actually, right? But yeah, what we forgot about was the ordered property, and Kritika had explained that in binary tree it follows some kind of an order. Okay, so subtree of a general tree do not hold the ordered property, while subtree of a binary tree hold the ordered property. Okay, fine. 2 types of traversals of a binary tree: pre-order, post-order, and the third one is in-order. Pre-order means ancestor first. Yes, pre was related to the ancestor, is what we established yesterday. So you're gonna start from the root node. The first thing will be root node. Then you go to the left subtree, starting from the ancestor, and then the descendant. So 1, 12, 5, 6, and then 9. And then if it's a post order, then we go from, just 1 second, let me connect my headphone. Yeah. So am I audible?
Yes.
Okay. So in the post order, it goes from child to parent. So we start from 5, then 6, 12, and then 9, and then finally root will be at the last. So post order is just the reverse of the pre order. Then finally we have in order. In order, you first complete the left subtree, go to the root, and then do the right subtree. So we'll start from 5, 12, 6, 1, 9. Let's see. Each node is visited before its children are visited. Root is visited first. So visit root node, traverse the left subtree in pre-order, traverse the right subtree in pre-order. So 1, 12, 5, 6, 9, which is correct. Each node is traversed only once. The time complexity of the pre-order traversal is what? Tn equals what? On? Yeah. Time complexity is, and where n is the number of nodes in the tree. Okay, post order. The children of the node are visited before the node itself. The root is visited last. Every node is visited after its descendants are visited. Algorithm for post order traversal is traverse the left subtree in post order, then traverse the right subtree in the post order, and then visit the root at the last. So just remember one thing, that in the pre order, you visit the root node at the first, and in post order, you visit the root node at the last. So you go 5, 6, 12, 9, and then 1. As each node is traversed only once, the time complexity of the post order traversal is Tn equals On, where n is the number of nodes in the tree. In order traversal, you go traverse the left subtree, the root node, and the right subtree, just like forming a shape of L. So it's 5, 12, 6, 1, and then 9. Moving on, binary search with example. So what is a binary search? So in binary search, basically takes advantage of the fact that the elements are sorted in an ordered way or sequential order, and it divides the array into two parts by picking up a middle element. It checks if that element matches the element that is being searched. If it is, then it's going to return that element. Otherwise, it's going to check if the element that you're trying to search is greater or smaller than the mid element. If it is greater, then the right part of the list will be picked up, otherwise the left. Let's say if it's the left, then the left set of elements will again be divided into two parts, and the middle element is going to again be compared, and this process is just going to be repeated until you find the element. So binary search is a searching algorithm which used in a sorted array by repeatedly dividing the search interval in half. So the thing to remember in this, that two things mainly. One is it's used in sorted array, and second is uh, it repeatedly divides the search interval in half. So keyword is search interval, and we have to divide it in half. The idea of binary search is to use the information that the array is sorted and reduce the time complexity to O n log n. And begin with the mid element of the
Just
whole array as a
log
search key.
n,
Sorry,
not n
did
log
I say
n.
n log n? Okay,
Yeah.
okay, I'm used to, I guess, n log n. That's why. Thanks for reminding. Okay, so begin with the mid element of the whole array as a search key. If the value of the search key is equal to the item, then return an index of the search key. If the value of the search key is less than the middle element of the interval, decrease the interval to the left half, otherwise decrease it to the right half. Repeatedly check from the second point until the value is found or the interval is empty. So may I go ahead and read this?
Binary search is a searching algorithm used in a sorted array by repeatedly dividing the search interval in half. The idea of binary search is to use the information that the array is sorted and reduce the time complexity to O of log n.
And no, I'm not going to accept that. O of n log n. You said that. Okay.
Algorithm. The basic steps to perform binary search are: begin with the mid element of the whole array as a search key.
Mhm.
If the value of the search key is equal to the item, then return an index of the search key.
So we have to return the index, not the item itself. Okay.
Or if the value of the search key is less than the mid element of the interval, decrease the interval to the left half.
Hmm.
Otherwise, decrease it to the right half. Repeatedly check from the second point until the value is found or the interval is empty.
Okay. Kritika?
Yes, binary search is a searching algorithm used in a sorted array by repeatedly dividing the search interval in half. The idea of binary search is to use the information that the array is sorted and reduce the time complexity to O log n.
Okay. So it is used in the sorted array by repeatedly dividing the search array into half. So sorry, search interval into half. Let's underline this part. Repeatedly dividing the search interval into half. Okay. So the searching algorithm used with sorted arrays by repeatedly dividing the search interval into half. Okay. The idea of binary search is to use information that the array is sorted and reduce the time complexity to not O n log n, but just O log n. Okay. Cool. Go on.
The basic steps to perform binary search are:
Mm-hmm.
begin with the mid element of the whole array as a search key. If the value of the search key is equal to the item, then return an index of the search key. Or if the value of the search key is less than the mid element of the interval, decrease the interval to the left half.
Why do I feel like by the end of you finish this slide, you're just gonna die?
Oh, it's just so. I have something.
Exhausted?
Huh?
Exhausted?
No, no, it's just something that happens right before the exam. I panic a lot.
Whoa. Okay.
Yeah, I've
All right.
done that for literally all of my exams since I guess 11th grade. 11th.
Oh, okay.
Yes.
No
So
worries. Carry on.
it's not exhaustion, it's just I'm getting scared.
Exam fever. You're getting exam fever.
Yes. Yes, I have like extremely cold feet right now.
Okay. Okay. Don't worry.
Yes.
Imagine if tomorrow's paper goes well, like whatever we studied, that comes. Fingers crossed. I mean, we can't say much. We can't say much with these IGNOU people. Hope they're listening to us. Please record it.
Is it
Okay.
live?
Yeah, it is live.
Okay.
Everything we speak is live. Go ahead.
Or if the value of the search key is less than the mid element of the interval, decrease the interval to the left half.
Okay.
Otherwise, decrease it to the right half. Repeatedly check from the second point until the value is found or the interval is empty.
Okay. So it's a searching algorithm used in the sorted array by repeatedly dividing the search interval into half. The idea of binary search is to take advantage of the fact that the array is in sorted form, and it should reduce the time complexity to O log n. And the basic steps are: start from the middle element of the whole array as a search key, and then if the value of the search key is equal to the item, then return the index of that particular search key. And if the value is less than, then decrease the interval into left half. If the value is greater, then decrease it to the right half. So kind of eliminating anything else. So like checking off the right part in case if it's less than the mid element, and vice versa. So it's kind of reducing the size of the um searchable items by reducing the array. I repeatedly check the second point until the value is found or the interval is empty. Moving on. Don't really need to think that we have to explain all of this. Just move on. Okay, algorithm for addition of two matrices. Somebody was supposed to write this. Okay, let's take a look. Okay, declare and initialize two-dimensional arrays A and B. Calculate the number of rows and columns present in the array as dimension of both arrays is the same. Store it in a variable rows and columns respectively, and declare another array sum with similar dimensions. Loop through the array A and B and corresponding elements A1 1 plus B1 1 sum 1 1 display the elements in the array. Let's take an example. Algorithm for adding two matrices. Java or C. C. Okay, this looks good. So this is the program. I think the way to do it is just to take a look at the program. Oh, this looks big. Why can't they format it properly? Online C compiler. Sumaya, can you move the Kruskal's algorithm into this list of blue slides? I think
Yeah.
Anirudh had moved that outside, so we can cover that. But yeah, how they've written it. 1 plus 1, 0 plus 1, 1 plus 1, 4 plus 2, A plus B, okay, IJ. Yeah, this looks small. Oh, they're doing in Python, in Python. Let's see. This looks better. Okay, let's say rows and then columns. Then initialize the matrix of A. Why is this empty? Should be 3, right? Okay, so this guy's got 3 by 3 rows and columns, and this guy's got 3 by 3 rows and columns. Great. Then rows, calculate the number of rows, columns present in the given matrix. I would say forget about it, just put 3 there. So reduce the complexity. Just need to understand. Okay, end sum rows and columns. Okay, array sum will hold the result. Why don't we just put 3 and 3? And then performs the addition of the two matrices A and B, store the result in the matrix. So loop through the array and just say ij equals ij plus bij. I think this is the loop that we are looking for. This should help. There's nothing else going on here. Just kind of saying sum ij equals aij and bij. So the two things that will help us remember this algorithm is this guy. We'll probably get rid of this for now. This is the main thing. Okay. And this guy. And then this is the algorithm. This is enough. And we'll put it into our own words so it's easy for us to understand. Okay, I'm going to zoom this in. It's better. Okay, so declare and initialize two-dimensional arrays A and B. Okay, we're doing that. A and B. Calculate the number of rows and columns present in the array A as the dimension of both and store it in the variable rows and columns respectively, which is what is happening here. Rows, rows and columns respectively. Declare another array sum with similar dimension. You can say sum 3 3 Loop through the array A and B. Okay. And add the corresponding elements. Are they looping through both A and B here? Like for int I equals, for j equals, example A 1 1 plus. It's actually the reverse. We should be writing reverse. And we should really be just writing whatever's written here. So sum ij equals a ij plus b I j. I think this will be simpler to remember. Display the elements of the array sum. Array sum means sum array. What? Man? So at this point, if you want to just write the program part, like initializing, we can write it just for our own reference. So in our head, we kind of think of that program. So declare and initialize two dimensional arrays A and B. So that's what's happening here. How can I put it there? I'll put it in small. Where it go? Yeah, we'll have some space for this now. So declare and initialize two-dimensional is A and B. That's fine. Okay. And in the bracket, we can say A33, comma B33. Okay. Calculate the number of rows and columns. This doesn't belong here. We can say for addition of two matrices, the number of columns of number of rows. What was the condition? Where was it? Yeah, if they have same dimension. Okay, then declare and initialize two-dimensional A and B, which is this happening here. Calculate the number of rows and columns present in the array and store it in the variables rows and columns respectively. Calculate the number of rows and columns present in the array and store it in. Okay. So I'm not going to put the program to calculate. I'll just say row equals 3 and column equals 3. What are they doing? I just added that, but I think they had added some program there. Yeah, size of something. Oops. became so small that it turned upside down. Come on. Ah. Okay, fine. Declare another array sum with the similar dimension. So you can probably say int sum. Okay. Loop through the array, which is happening here, and add the corresponding elements. Example so and so. Display the elements of the sum array. Yeah, I will move these guys properly later on, but I hope you get the idea. You guys are there or left?
We're here.
Yeah.
Okay, no problem. So you understand this, right?
Yes.
Or no?
Yeah.
Okay, let's go take a break. And what time do you want to start now? So just to tell you what we're going to do basically after this. Once we come back, we're going to finish these blue slides. Once we finish them, we're going to do the algorithms. Kritika, you were going to take through couple of sorting, and so Maya was going to take us through couple of sorting methods,
Yes.
right?
Yes.
Kritika, you ready with that?
Yes.
Okay, so yeah, once we come back, we'll finish the slides, which are not many left, just a few of them, and then we'll do that. And once we finish that, then we will go through this non-important slides and just read through them, just trying to grasp some information so we can at least use them tomorrow in case if they come, like a backup plan. Okay.
Yes.
So what time do you want to start?
I'm okay whenever.
At 9
Uh,
o'clock?
9 o'clock. Yeah, let's do 9 o'clock. That sounds good.
Okay.
Okay, bye.
Just one more thing. Imran, can you tell me
Yeah.
if the slide, if the rest of the slides,
Hmm.
do they cover like everything from the
Yeah.
book? They do?
They do.
Okay.
Yeah.
Okay,
But
fine.
for many of the slides, I've just put
There,
topics. I've not
yes,
really
that's
put
fine.
content.
Yes, that's
So
fine.
if you ask me, all the rest of the slides cover all the headings or the syllabus, but not everything has a content. I can see that majority of them have content because you guys have already put that. I can rarely see slides where the content is not present. So yeah, so that's good actually. So we won't
Yes.
spend too much time on them. We'll just try to spend enough time so we at least get some idea what they're talking about. And if
Yes.
anything is taking too long, we'll just move on to the next slide.
Yes. Okay.
Okay, thanks and bye bye.
Okay. Bye bye.
Okay, bye.